The geographical reality of Peru is that it has mountains in the central part. The small cities are located in the valleys and places that are difficult to access. Some time ago we had to link the towns of Paccanas and Winapi. Winapi is a very small town without internet access, and Paccanas is a larger city that does have internet access. So we had to give Waipani access through Paccanas. As you can see, the two towns are shown in this mountainous geography. As seen below, there is no line of sight between the two locations. No special software is needed to see that there is no line of sight. It is evident with the naked eye, so we must look for a repeater that will help us reach Winapi. Then we are going to use the ACPLINK software to define in a simple and easy way a point that allows us to locate a repeater, for which we have already entered the coordinates of the starting point, which is Paccanas, and the end point, which is Winapi. As seen in the ACPLINK software, there is no line of sight. There is a large obstacle that prevents communication via a microwave radio link. Also note that the geography is mountainous and does not help much. We must search carefully to optimize the number of hops that we must use to reach Waipani. The tool that we are going to use to locate a repeater saves a lot of field work time, because it can be done in the program easily and very quickly. The interface that we are going to use is NASA's Global Wind, and it has very up-to-date information of all the Earth. There are several ways to solve this problem of locating a repeater. For example, we can use a tool that allows us from Paccanas to draw lines in the direction of Winapi, and see if there is any place that has a line of sight with Paccanas, and from that new point continue to Winapi. Note that while the cursor moves, the profile from Paccanas is updated in real time. This way we can know at the same moment whether there is line of sight or not. This saves us a lot of time planning the radio links. The classic way of solving this is putting two coordinates in a software and evaluating whether or not there is line of sight. However, with the ACPLINK software we can do this simultaneously. This tool is advisable when the starting point and the end point are very far away, for example 300 kilometers, then you must go from jump to jump until you reach the end point. However, in our case the distance is relatively short, so we are going to use another tool that I developed based on my needs when I have had small projects that include short distances and repeaters must be located very quickly. So, we are going to use a more appropriate tool. For our need to locate a repeater between 2 points, we must choose the 2 points and assign them values such as antenna heights, frequencies, safety margins or clarity for each radio link, because they will be generated 2 radio links. The first will be between Paccanas and the repeater, and the second is between Winapi and the repeater. Now we have a graphical interface that shows us two profiles in real time. Those are the two profiles that the ACPLINK software shows to evaluate in real time whether there is line of sight or not. In the background image with the 2D geography, we can see that if there is line of sight, the lines turn blue, but if there is no line of sight, the lines turn red. Now we stop the search in a place that meets certain requirements. For example, the possible location of the repeater is near a road, so the logistics of installation and maintenance are guaranteed. Likewise, the security required for the station repeater can be accessed by hiring local security personnel. We can also deduce that if there are homes or work offices in that place, it is very possible that they have electrical energy to power the repeater equipment. And then we click on CT or L+D and capture the point that we are pointing with the cursor. It is not necessary for us to manually enter the coordinates of the site. The program already does it automatically. Now we will see an analysis of the profile that is necessary. When you have very high obstacles, you must be careful with the clarity or safety margin, which is the vertical distance between the imaginary line from antenna to antenna and the most critical obstacle. These values safety margin is required by customers or cellular telephone operators who operate with standards recommended by the ITUR. An important aspect to consider is to locate where the reflected waves are concentrated. ITUR and its predecessor to recommended a method to identify this point. The ACPLINK program locates this point and provides its coordinates. Why it is important to locate this point? Well, why if this point falls in some body of water, that could be a lake, gulf or part of the pair, then the location of one of the stations must be changed because the reflected waves would do a lot of damage to the radio link. That is why it is important to know whether or not the reflection point falls in a mass of water. Also note that the reflection point is obstructed by the same geography, and this is beneficial for the radio link. If we accept the repeater as valid, we can now see in Google Earth the two jumps or radio links that we have found to join Winapi and Patcanas. Note that the ACPLINK program integrates the Google Earth program into its application and uses it as a presentation tool because Google Earth offers a very nice and descriptive view of the radio link. Now, we are going to review the link budget of the radio link, as seen below. The ACPLINK program incorporates a database that the client must complete with the equipment they use the most. The same for the transmission lines and antennas. Now, we have some equipment that we have already entered before, and we are going to use them to calculate the availability of the radio link. We just have to choose from the list of available equipment, and the program will extract the data to enter it in the graphical interface. We must also choose the mathematical model to calculate the availability of the radio link. In our case, we choose the Vigance-Barnett model. We also choose the type of terrain of the area in which the radio link is located. The RUNIS is calculated by the program directly according to the model that we have chosen. The program presents us with a report with the data entered and the availability of the radio link. This report is calculated in both directions. It is also possible to add factors such as temperature or rain, depending on the area where the radio link is located. In our case, in this area, it doesn't rain much, so rain doesn't count, and rain is especially harmful from 6 GHz. The program has several more tools that will facilitate the designer's work. I have always taken into account the ease with which we can use this tool, so I developed it with the philosophy of being very friendly and being a complement to speed up projects.